Welcome to our learning module covering the sensor element of our Danfoss pressure and temperature controls. By the end of this session, you will be familiar with the different sensing technologies that Danfoss uses. We will also go through the control ranges, special features, and important things to consider when using different charges. Any pressure or temperature control consists of three basic elements: the sensor element, the switch element, and the setting element. In this module, we will go through the sensor element. Here are four of the most common technologies used in pressure and temperature switches. Danfoss uses three of these element types: bellows, diaphragm, and spring-loaded piston. These are indicated by the Danfoss logo. Most Danfoss controls use the bellows technology. Here is the range of Danfoss pressure switches, Danfoss differential pressure switches, and Danfoss temperature switches. Take a look at the table to see which sensing technologies and which accessible pressure and temperature range each type uses. In the RT and BCP series, Danfoss offers pressure controls with double bellows. The inner bellows, illustrated in dark gray, contains the pressure during normal operation. However, if this bellows fails and begins to leak, the medium enters the larger bellows. Because of the larger surface area, the same pressure generates greater force and causes the switch to activate. This protects the system by not allowing the charge to escape into the atmosphere. Danfoss thermostats function by creating pressure from a chemical charge in the sensing bulb. There are three different charges that can be used: the vapor charge, the partial charge, and the absorption charge. On the following pages, we will take a look at the advantages and disadvantages of each type. The advantages of the vapor charge are fast reaction, pressure limitation at over temperature, element pressure completely independent of ambient temperature, and very small sensors. The disadvantages are that units with this charge can be used only where the sensor is the coldest part of the element, and that the differential is also very dependent on the range setting because of vapor pressure gradient. The advantages of the partial charge are fast reaction charge and element pressure completely independent of ambient temperature. The disadvantages are that units with this charge can be used only where the sensor is the warmest part of the element, and that, because of vapor pressure gradient, the differential is very dependent on the range setting. The advantages of the absorption charge are that the reaction is always in the sensor, the differential is mostly independent of range setting, and there is a quite good pressure limitation because of the low element pressure gradient at high temperatures. The disadvantages are that a low element pressure gradient most often means a slightly higher minimum obtainable differential, and that the element pressure is also affected by bellows temperature, which leads to a certain degree of capsule sensitivity. When using thermostats, there is a measurable delay between a change in fluid temperature and the response in the temperature switch. This is due to the time it takes for heat to transfer from the fluid through the sensor pocket and into the bulb, and the time required for the chemical charge to act. This delay is called the time constant. Thank you for taking the Pressure and Temperature Control Sensor Element module.